In the last video, we talked about how you can take your API and put it behind a load balancer to basically scale it out, right? So if you have a load balancer over here, you can have that sit in front of your APIs so that you can kind of distribute the traffic using either a round robin approach or like a sticky session type of approach. But these all end up hitting a database, right? So you're going to have a database somewhere, and these are all going to interact and try to hit the database with their own connections and try to fetch data and store data. And for the most part, this can handle quite a lot of traffic. And we're going to kind of walk through in this video how you can scale up a database to handle more scale. Now, when it comes to databases, there are quite a lot of databases. Some of them are already built with scaling in mind, like MongoDB is basically built with this ability to have clusters and shards. You have DynamoDB, which again is like a giant key value store. Of course, you have stuff like Postgres, which is a relational database where I'm probably going to be kind of focusing on Postgres for this video, but just keep in mind that depending on the database, some of them out of the box already have adapters and, architecture built into it, so you can quickly and easily scale up to other nodes. But let's assume that we have a Postgres database, and that's kind of the default I would recommend that you use when you're building out a system. Now, the first obvious step to scaling a Postgres database would be to do vertical scaling. So you may start off with a smaller box that has 2 cores and 8 gigabytes of memory, but over time, you may notice that your CPU usage is increasing too much or your memory pressure is increasing too much on the Postgres machine. Hopefully you have monitoring set up to see that stuff, where basically you just need to start allocating more CPU in memory to the box. And I would recommend that this be the first line of defense for scaling out your database. If you notice that you're getting a lot of traffic, just scale it up. Keep on scaling until you reach a point where you hit some type of bottleneck that requires you to find another approach to scaling. So step 1 would be vertically scaling your DB instance. And if you're using something like AWS, it's very easy to just change the configuration of your instance and watch it scale up. Okay, the second thing you should probably be focusing on when it comes to scaling up your database is make sure that you have indexes set up on your table, so proper indexes. When it comes to Postgres, typically you have a table, and you're supposed to be putting specific indexes where you're doing a lot of where clauses. So for example, let's say you have a table that has millions and millions of users, and on each user record, you have an age. So user.age, and you want to find where all users are greater than a certain age. So where user.age is greater than, and we'll say like 65 or something like that. Maybe you want to give like a senior citizen discount and send off like a mailing list to all those people, okay? Adding some type of index on age may be beneficial because now in order to get all that data, if you don't have the index, it's going to scan through your entire table, which could be very slow and problematic. So adding indexes to some type of key inside of your most common query clauses can make your queries run a lot faster and also reduce the load on your database, right? Imagine all that data, it has to fetch it and then put it in memory and then scan over it, versus if it already has a way to fetch that real quick from the B tree that's internal to the Postgres database, you're going to get that data very fast. Now, the third thing I want to talk about is connection pooling. So inside your APIs, if you are deploying these as containers or just standalone services, typically whatever SQL client that you're using like Drizzle or Type ORM will have some type of connection pooling mechanism built into it. But if you're using something like serverless, where this could fan out and have tons and tons and tons of connections trying to connect to this Postgres database, you may have to add in something else in between your Lambda functions, or AKA your serverless functions, and your database. And that is called a connection pool service. So PG Bouncer is one common thing where instead of your API connecting directly to your Postgres database, they would all open up connections to PG Bouncer, and that would limit the amount of connections that actually go to your Postgres database. So you will potentially hit connection limit exceeded when trying to connect too many things to your Postgres database. So you either need to figure out a way to reduce the amount of connections your APIs are making, or put something in front of your Postgres database, such as PG Bouncer. The fourth thing I want to talk about when it comes to scaling a Postgres database would involve some type of read replica, okay? Now, from what I've seen with Postgres, typically you'll have a primary database, but you can also have something called a replica. So basically, you have another database that's basically on standby, and as users are writing to your primary database, it's going to replicate that data over to your replica, right? So replicate all writes to replica, and this would be called your read replica. Now, how this helps in terms of scaling, instead of having every single select query go through your Postgres database here, you can have the writes go to this Postgres database, and you can have the reads, the select queries, read from your read replica. Now, granted, there could be some type of delay in terms of the data. So if having some type of consistency with your data is important, then maybe you want to read from your actual primary database instead of your read replica. But this is another approach to allow you to have a lot more connections, because now you basically double the amount of connections that you can have. So you might have stuff connecting to this one, you could have stuff connecting to this one, and that would reduce the strain on the databases itself, right? Now, not only does this help with scale, you can have this read replica live in another region so that you can have users from your West Coast of the US be able to read data much faster than having to all go to that primary node. So it kind of addresses the user experience of having faster load times and fetches from the database, but it's still, when you have to write to the database, you do have to have basically a primary, especially if you want, consistency with your writes or transactions. Now, the fifth thing I want to talk about is caching. So 5 would be caching. And this could be achieved by using Redis or memcached, where basically instead of your API going to PG Bouncer directly or trying to connect to the database directly, instead it could connect to a cache first and see if that thing has the query or the data that you're looking for. If not, you could then have it go to the actual database, right? So again, caching is a very, very common pattern we do in software to make stuff load faster. But there is a trade-off with how caching kind of works, because again, sometimes you don't want users reading stale data. You want them to be able to have the latest up-to-date data, and caching can kind of make things a little bit more challenging. But this is an approach as well. And often with Redis, you do have the ability to set up like a cluster, and you can have common SQL queries cache the results inside of Redis so that we don't have to keep on fetching from the database every time and reduce the strain on the database. So the sixth thing I want to talk about is partitioning your data. So when you have a ton of data, sometimes the only approach you can take to scale this up is to split up your data into separate tables. So instead of having, for example, all of your users live on the same table, you could have 3 or 4 different tables called users 1, users 2, users 3. And then you can partition all your users based on the first character grouping of their first name or whatever, or their ID, and put that into separate tables. But this will allow you to have your giant users table split up into many different tables to kind of reduce the strain that you're using to have to search through all of them, right? Another good example of this is if you have a table for storing a bunch of logs or historic records of something. At some point, you're going to have so much data in that table that it may make sense to make a brand new table and partition it by the year. So 2026, 2025, you have a brand new table each time, and your application logic can know to store it in a particular table based on what the current date time year is. Now, the last thing I want to talk about is basic query optimization. So if you do an explain analyze on your SQL queries, it can kind of tell you how the query planner decides to execute it. And in that execution, it can kind of tell you which things are taking the most time or using a lot of the cycles of the database. I would say one of the beginner basic rules of thumb of database scaling is not only can you just give it more resources, but also reduce the strain that you're putting on your database so it can handle more traffic. I think the last thing I'll mention is that out of all the things I mentioned here, if you're working on a smaller company or a side project or a startup, I would say you probably don't need most, if not any of this, right? For the most part, you can probably get away with just having one database and just vertically scaling it up until you reach that breaking point where you need to find some other type of optimizations. And at this point, there are so many existing database SaaS products like PlanetScale or AWS RDS that handle scaling for you that I would probably just recommend from the get-go, just use one of those database services. They are going to cost more, but they give you the flexibility to turn a toggle to start handling more traffic right out of the box. But if you have any comments or anything I misexplained, please call me out in the comments so I can improve not only my own teaching abilities and my own understanding, but also so other people watching this can get accurate information. There are probably a lot of things I did not mention, and you guys can leave comments below if you think there is something that I should have mentioned. All right, have a good day and happy coding.